Hi friends, welcome to Shraddha Tutorials. So today we are going to solve first problem from second exercise from the chapter real numbers of class 10. Okay, now see what is a first question. So they asked you to represent these numbers in terms of a product of its prime factors. Okay, so this is nothing but a prime factorization. So I hope you all are aware of prime factorization. Means like representing a composite number in terms of product of its prime factors. Okay, for an example, if there is a number 8 composite number, this can be represented as 2 into 4, isn't it? But here 4 is a composite number, so this has to be again written in terms of product of prime factors. So 2 is a prime factor for 4, so I can write finally as 2 into 2 into 2. See, 2 as it is I have written, this 4 can be written as 2 into 2. So if I multiply these 2 into 2 4, 4 into 2 8, okay, or even I can write this as 2 to the power of 3. This is what prime factorization, and now we are going to imply same to the given problem. So first, what they asked you, 140. How can we write this as 140 can be written as 2 into 70, where 2 is the prime factor and 70 is the composite factor. So we should not see any composite numbers here. So this has to be again written in terms of product of prime factors. Okay, how to write them? See, these two as it is I have written, and 70 can be written as 2 into 35. Means 2 times 35 is nothing but 70. Okay, now this 35 is again a composite number, and that can be represented as 2 into 2 into 3, not 3, 5 into 7. 5 into 7. So this is what the representation of product of prime factors for 140. Okay, this can be written as even 2 to the power of 3 into 5 into 7. Okay, now let me solve second one. 156. 156 can be written as 2 into 78 times. 2 78s are 156. Okay, if you want, you can do one thing. Take least prime number and divide this number. So how many times you are dividing, that you have to write here into divisor. Okay, now 78 is a composite number, and it has to be mentioned in terms of prime factors. So you take again, so this is an even number, it can be divided by 2. Okay, so 2 into how many times? 39 times. 2 39s are 78, and this can be written as 2 into 2 into 39 can be written as 3 into 13. 3 into 13, 3 13s are 39. So this can be written as 2 to the power of 2 into 3 into 13. Okay, so this is the procedure to solve the second one. And what is the C? 3825, 3825. See here, this is a big value. So to start with the least prime number, of course it is an odd number, so we can't start with 2. So if we go for a divisibility rule, then easily we can say whether this number is divisible by 3 or not. Okay, so whatever may be, it's not only for 3, for any other number. Okay, yes. If what is the divisibility rule for 3? If we sum the digits of the number, and if the sum is divisible by 3, then the whole number is divisible by 3. Okay, let us 3 plus 8 11, 11 plus 2 13, 13 plus 5 18. So 18 is divisible by 3, and so whole number will be divisible by 3. Then how can we represent this? Let 3825 is equal to, so now we said 3 means this number can be divisible by 3. How many times? So 3 ones 3, 3 twos 6. So here we will be having 2, 22, 7 times 21, and you will be having 15. So 15. How many times? 5 times. 3 5s 15. Isn't it? Yes. No. See, this is a composite number. Why? Because it can be divisible by 5. Is it not? So let me check whether 3 divides this number or not. So 1 plus 2 3, 3 plus 7 10, 10 plus 5 15. So 15 is divisible by 3. So whole number will be divisible by 3. Now let us see how many times it will divide. 3 4s are 12. 3 twos 6. So you will be having here 1, so 15, 3 5s. Okay, now 425 is again composite number, so it's divisible by 5. Maybe it may divisible by 3 also. Let me check. Okay, 4 plus 2, 6, 6 plus 5, 11. So 11 is not divisible by 3. So this number is not divisible by 3. So it will be divisible by 5. Next prime number is after 3, 5. Okay, yes, let me divide with 5. How many times? 42. So 8 times, 5 8s are 40. So you will be having 2. So 2, 5, 25. So 5 5s, 25. Isn't it? Yes. Now let me divide again this. See why? Because 85 is a composite number. It will be divisible by 5. How many times? 5 into 17 times. 5. How many times? 17 times. So this can be written as 3 square into 5 square into 17. Isn't it? Yes. Now fourth one, D. That is 5005. See, this can be written as, this can't be divisible by 2, not even 3. Why? Because sum of the digits is 10. 10 is not divisible by 3. So we have to go for 5. Yes. So with 5 we can divide. How? Like, let me write 5005 is equal to 5 into 1001. Isn't it? And now 1001 is again a composite number. So we can't divide with 5, so we have to go for next prime number, that is 7. Okay, so this number is divisible by 7. How to check whether a number is divisible by 7 or not? Okay, so let me take example of this only. Okay, na? Yes, 1001. So in divisibility rule of 7, what we have to do? We have to take last digit and we have to double and subtract from the remaining number. Okay, now see, if I subtract this 1, then this will be 100, isn't it? So double of 1 is 2. If I subtract from 100, I will be getting 98. And if I divide this 98 with 7, means with the remaining, if I divide with 7. So let me check. 7 ones are 7 and 2 is the remainder. And if I take this 8 down, 4 times 28. Yes, I got remainder 0. So this number is divisible by 7. Okay, now let us check how many times you can divide 1001 with 7. Okay, so how many times in the sense? So if once we come to know how to divide, whether the number is divisible by 7, then we can go for normal division or whatever maybe. Okay, how many times? Like 7 one time, so 7, and you will be having 3, 30, 7 4s, 28. So from 30, 28 is removed, subtracted, 2 will be there, 21. 21 means 7 3s are 21. So 143. 143, isn't it? Yes. Now, see, 143 is again a prime number, a composite number. It has to be written in multiple of prime factors. So with what we can divide? See, 7, let us divide with 7. No. Why? Because 20s are 140. So 3 is the remainder. So no chance. Next number is 11. See, what is the divisibility rule of 11? If sum of difference of the sum of alternate digits is equal to 0 or multiples of 11, then the number is divisible by 11. Okay. Now see, if I add alternate numbers, 1 and 3 are alternate numbers. 1 plus 3 is 4, and one number 4. 4 minus 4 is 0. So this whole number is divisible by 11. Okay, now? Yes. How many times? 11 into, let me divide 143 by 11. So 11 ones are 11. So 3 will be there. 3, 33. How many times? 3 times. So 11 into 13 is 143. So this is the representation, it's a prime factorization for 5005. Okay, and now let us solve last problem. Now E, that is 7429. So 7429 can be written as multiples of what? You can use the divisibility rule of 2, 3 and next other prime numbers up to 11. So you know very well, and up to 11 you can't. So means those prime numbers will not divide that number, and so you have to go for 13. Next 17. Okay, so 17, 437 times, you will be getting 7429. Okay, now next again 437 is a composite number, and it can be written as multiples of 17. Let me check with 17. So if 17 is able to divide, then 17 into some number, isn't it? So it doesn't, no, it will not be divisible by 17. It will be divisible by 19, 23 times. So 19 into 23. So this is the means representation of product of prime factors for 7429. I hope you understood this. Thank you for watching this video. Thank you.